Meghan VanderMale. I'm a math professor in the math department at GRCC. And I did a sabbatical in the fall of 2020. And I studied gerrymandering and kind of the mathematics behind it and ways of incorporating it into some math teaching. So I'm going to share a little bit about that today. One of the things that I also did is I followed the work of the Michigan Independent Citizens Redistricting Commission. So a lot of my presentation is going to follow some of the work that they're doing and some of what I did and how it relates. Okay, so I'm going to start out by just summarizing a little bit of what I did during my sabbatical and why I wanted to do my sabbatical over this topic. I spent a lot of time reading and learning. So I read books, I watched webinars, I researched articles, and I was focusing on the mathematics and mathematics education around gerrymandering in particular, but also voting and elections. I spent a lot of time writing puzzles and questions. So this is something that I had been doing already for my Math for Liberal Arts classes, but I wanted to kind of expand that and collect different things that I had been working on over the years. I also wrote a math seminar course, which is going to be Math 293, Math and Politics, and that's going to be offered in the spring, so the first half of the summer. It's a 7-week class. So I was planning for that. I started a blog called Paloku, and that's just a collection of the different puzzles that I wrote. And this was just kind of a way for me to collect everything together that I had been working on and also kind of start putting it out there so it's more accessible. I also wrote an article on a classroom activity on compactness that I had been doing for a while for my Math for Liberal Arts classes. And then I also followed the work of the Michigan Independent Citizens Redistricting Commission. So I'm just going to start with a little bit of history about redistricting in Michigan, recent history. So in 2018, Voters Not Politicians started this grassroots movement to amend the Michigan Constitution. And the idea was to take redistricting out of the hands of the politicians and put it in the hands of citizens and also make it very visible so that everyone could see what was going on and the reasoning for why lines were drawn in particular ways, and also just to make input from everyone be more accessible. So this, it was Proposal 2 in 2018, and it passed overwhelmingly. It passed with over 60% of the vote, which is a significant amount. And so now, in the end of last year, they put the commission together. So this was collected using applicants, so people could apply, and then they randomly selected people to be on the commission. It's made up of 4 Democrats, 4 Republicans, and 5 independent citizens. And I have a resources page at the end of this that has more information, so if you want to see how that selection process worked, that is there. So they're going to be using the 2020 census data to draw the district lines. This is going to be significantly delayed because of the way the census has gone this past year. So they're in a little bit of a time crunch, but that is what they are working on. They are going to be drawing 3 sets of maps. So I have 2 of them here. So this one is the Michigan House District. So there's 110 of them. That's as it is currently. So this is from the 2011 apportionment plan. So that was from the last census. This is my favorite map of the Michigan congressional districts. There's 14 of them. This is from the Detroit Free Press. So this is called Jerry Monstered. I also have a link to this at the end if you want to see it. So this was one of their cartoonists kind of poking fun at the odd shapes of the congressional districts. So you can kind of see them here, but then he just turned them into different monsters because of the shapes. So the commission will be redoing these two maps as well as the Michigan Senate map. So in drawing these lines, there's 7 criteria that the commission has to follow. And what is kind of nice about the Michigan process is that the constitutional amendment outlines the 7 criteria in order of priority, which is not always the case for line drawers. They don't always have it spelled out what their priority should be, so this is kind of a benefit. And what I'm going to be doing in the presentation is going through those 7 criteria. And for some of them, I have puzzles that kind of go along with them and explain what they mean. So if you want to follow along with these puzzles, you can find them on my blog. So I posted them either in PDF form or in a Google Jamboard. So if you want to do it digitally, you can do that as well. So if you're watching this, if you want to pause when we get to a puzzle, you can pause, try the puzzle on your own. The blog is this, so it's Paloku. And this name came from my students because when I do the districting puzzles in my Math for Liberal Arts classes, a lot of my students tell me that they feel like they're doing a Sudoku. So I merged the word Sudoku with politics, and that's how we got Paloku. So it's palokupuzzles.com. And there's a post that is related to this presentation. It's titled GRCC Presentation March 2012 or 2021. So you can find it there. And then, when we get to a puzzle, I'll let you know, and then you can pause and look at it if you would like to. Okay, so these are the first 3 criteria. So the first one is that districts have to be of equal population and comply with the Voting Rights Act. This is the most important one. They definitely have to follow this one. B says that districts have to be geographically contiguous. And I'll talk about what that is in a minute. C says districts have to reflect the state's diverse population and communities of interest. D says districts shall not provide a disproportionate advantage to any political party. E says districts can't favor incumbents or disfavor incumbents. F, districts shall reflect consideration of county, city, and township boundaries. And then the last one is that districts shall be reasonably compact. So these are listed in order of priority. You'll see with some of the puzzles that it can be difficult to meet all of these at once. So the nice thing about having this prioritized is when they're drawing the maps, if they can't meet all of these, they have to give up some of them. They know which ones need to be given up in which order. Okay, so we're gonna go through all 7 of these. The first one is equal population and the Voting Rights Act. This is the most important one. The Voting Rights Act has a couple different sections to it. Some of these sections have kind of lost a lot of their power because of different cases that have gone through with the Voting Rights Act. In fact, right now, there's some question about how powerful the Voting Rights Act is going to be in the future because the Supreme Court is looking at some cases related to it right now. But in terms of redistricting and drawing the lines, probably that won't change anytime soon. One component of this is that we have to have equal population in all districts. Why is that? Well, if you look at this example, so this is one of the puzzles that you could try on your own. But before we get to the task involved in this puzzle, if we imagine, let's say I'm just doing 3 districts here. So if I just make this a district, this a district, and this a district. Notice that this district right here would have a lot more people in it than this one, and this one as well. So if you're in a district that has fewer people, that means that your vote counts more, right? Your vote has more power in it because there's less people that are contributing their votes. And so that's why we have to have the same number of people in every district. So that has to be true with all 3 of our Michigan maps. And we can't get exactly the same number of people because there's a large population, but we can get pretty close. So it's a pretty small window of population that needs to be equal in all the districts. So for this puzzle, what I ask you to do is to split this map. So we're pretending that these are people. Split this map into 4 districts of equal population. So there's 80 dots total, so you don't have to count them all. So that means there's going to be 20 dots in each district. And you can split them however you want. I'm not going to go through there's a lot of different ways you can do this. And if you want to pause and do it now, you can. But I will say that I made this on purpose so that it wouldn't be super clear where the line should be drawn. So, for example, if you look at this cluster over here, I believe there's 23 dots. So if we're trying to split this up, it would be very nice if I could just make this a district. But to meet the equal population requirements, 3 of these dots are going to have to go somewhere else. So there's some decision making to be had here. Do I put those 3 dots over here? Do I put those 3 dots over here? What do we need to do to make sure we have an equal population, and how are we going to split those up? So it's not always extremely clear how to draw the lines in order to get that equal population. Another thing I'll say about this is the different colors don't mean anything. It's just so it's easier to count your dots. So that's the first puzzle. The other part of the Voting Rights Act, let me say this. So this is a map that I drew on something called Redistricting, which is also in my set of resources at the end. This is really fun. You can go in and they have old population data and you can draw your own districts. This one is not anything special. I just was trying to draw the congressional districts, the 14 congressional districts, so I could get an equal population. There's not really any other rhyme or reason to why I drew it this way. But I put it up here as an example of how, in order to get equal population, you often don't have equal size spaces. And this is because of population density. So if you look at northern Michigan, right, it's much less densely populated than even the Grand Rapids area. And so this district is huge space-wise, but it has the same population size as any of the other districts. And if you look over here at Detroit, we can't even see some of the districts without zooming in because they're so small, because the density, the population density is so high there. So that's why we get these different sizes. It's so that we can comply with equal population. Okay, the other thing I wanted to mention about the Voting Rights Act is Section 2, which says that minorities that have cohesive voting interests that differ from surrounding majority populations and are reasonably compact should be given the opportunity of significant electoral power through redistricting. So what this means is that if you have a racial minority in an area, so they're reasonably compact, it's not that they are spread out throughout another population. So if they're reasonably compact, and also they have similar voting interests, so policies or politicians that they are interested in that are significantly different from surrounding majority populations or even other minority populations in the area. We have to give them the opportunity to elect representation. That doesn't guarantee that they will be able to receive representation, but we have to draw the lines so that they have enough voting power in a district so that they could elect someone to represent them or pass policy changes that affect them. So that's what Section 2 says. The maps that I have on here, this one isn't the best quality, but this is the 110 districts from Michigan, the legislative districts. This is kind of the zoomed in version of Grand Rapids, so you can see the districts that we have in the area. And this is from a really cool map project. It's called the Racial Dot Map from the University of Virginia. And there's a dot for every person, and it's shaded according to race. So blue is white, green is black, and orange is Hispanic. Red is Asian, and then there's a brown dot for other. It's a really cool map. It's a map of the US. And again, there's a link to that in my resources page at the end. And it doesn't have any other landmarks on it. It just has dots for the population. So one thing that I did, just because I was interested, and I will say that I would assume that the information for this is not from the 2010 census. I would assume that it's a little bit more updated. So this map doesn't necessarily relate to this because the time in which the data was collected could be different. But I did kind of an overlay of this. So I took the Grand Rapids map and I just changed the transparency and I kind of put it over here just to kind of see how this played out in terms of race. And I'll change the transparency a little. Okay, so there's the dot map. And then there's the districts. And you can kind of see, I mean, I don't know for sure, but maybe this district right here was created to comply with Section 2 of the Voting Rights Act, right? Because we've got a large black population here, and so we've got a district where it appears like they probably would have an opportunity to have representation in that district. Now, there's a lot more that goes on in this. You really have to have a lot of experts that are doing a lot of data analysis to determine how to comply with this section. But this is just my guess about what's happening. And also, if you look here, I mean, there's this big orange section here. I don't know, again, this is just a guess, but I would think that the Hispanic community here is pretty compact, right? And depending on whether they have a cohesive voting interest or not, it may be that there needs to be another district here, so the Hispanic population kind of has their own district, depending on how similar these two groups might vote. So I thought that was kind of interesting and maybe thinking about how the maps could go in the future. Oops, hang on. Yeah. All right. Okay, so the next thing, so the first one was equal population in the Voting Rights Act. The next piece is contiguity. And contiguity is pretty straightforward. It just says that you can't have maps that are two separate pieces. They have to be connected in some way. So actually one of the mathematical ways or terms of describing this is connected. So we say that we have a shape that's connected. Mathematically, one definition for that is if you take any 2 points in the district, you have to be able to walk between those 2 points without leaving the district. So that's one way mathematically that we might define that. And I gave two examples here. This is Arizona, and this is in Chicago. So these are really funny shaped districts. So this purple one right here, this is, I think, the Hopi tribe that lives here, and they expressed interest. So Arizona has had a commission for a couple rounds of redistricting. I think they're the first state to have a commission. So their commission went around and they asked people, how should we draw these districts? What communities of interest are there? Who do you want to be in the same district with? And the Hopi Nation here said, we want to be with this area. And so in order to do that, they had to create this path that connected them in order to meet the contiguity requirement. So this is an interesting example because in this case, the weird shapes are actually good, right? Because we want to make sure that we're listening to how people want to be connected. But in order to do that, we have to have this strange shape. The same thing happened here in Chicago. This is commonly called the earmuff district because it kind of looks like a pair of earmuffs. And in this case, this was done to unite two racial minority groups. So we had I think this was a primarily Hispanic or Mexican populated area, and this was primarily Puerto Rican. So we had two Hispanic areas that had a lot of common things. You know, they shopped at the same places. They had a lot of the same political interests. And so in order to connect them and create one cohesive district, they had to go through this, and this is just connected via the highway. So they connected them this way. And in doing so, they avoided having to cut through this area, which was predominantly black. And so not only were they able to create a district that gave representation to a Hispanic area of Chicago, but they also were able to preserve black areas of Chicago as well. So these are nice to look at to see why shape matters, but sometimes weird shapes are good. So that's what we mean by contiguity. Okay, the third guideline is communities of interest. So I've kind of talked about this a little bit. So in the Voting Rights Act, the communities of interest that we're talking about are racial minorities, but you can have communities of interest around anything. They can be around, you know, maybe there's a geographical area where there's a lot of farmers, so that could be a community of interest. I heard of one example, I think this was in New York City, where there was a community of interest that was formed around a local historic theater. So there was this historic theater that a lot of people in the area really wanted to protect and make sure it wasn't torn down. They wanted to be able to preserve it. And so that group argued that we form a community of interest because there's policies that we would like passed to help protect this theater. So it really can be about anything. The University of Michigan has done some work on collecting communities of interest in Michigan. I think they have 1,000 plus identified. I also have a link to that at the end of my resources, so you can kind of take a look at that and see how they're doing work with communities of interest. This is going to be a big part of the work of the Redistricting Commission, is going out and talking to people and collecting information to decide what the communities of interest are. Once those are identified, the goal is to draw district lines so the communities of interest are in the same district. They might not be big enough to have their own district, but you want to put them in the same place so we're not splitting them so you've got folks in two different districts. So that's the goal. And then another thing I wanted to add is that just like when we're talking about racial minorities, communities of interest also have to be related in some way that is impacted by public policy. So if you have a group that says we all like board games, that is not necessarily a community of interest because that unless there's a convincing argument of why public policy is going to impact that group in particular in some way, that's probably not a community of interest. So that's the thing that makes a group a community of interest, is their interest affected by public policy somehow? Okay, so now I've got another puzzle with this. So in this one, we've got red dots representing a particular community of interest, yellow dots representing a community of interest, and blue dots representing a community of interest. And the goal here is to draw 3 districts. So we have an equal population. Now, I think there's 74 dots, so it's not going to be exactly equal, but you can get pretty close. So as equal as possible. And the goal is to draw your districts so that the red dots, which is one community of interest, are all in a district, the blue dots are all in a district, and the yellow dots are all in a district. Now, this is not going to be possible to do perfectly. There's no way to get it to work perfectly, but how can we do it so it's pretty close? So that's the goal with this puzzle. So you can go ahead and try that if you want. Oh, I think the way I framed that, because I had this on my blog at one point, I think the way that I framed it was, let's say we've got a city that's redrawing their school district lines, and they have the funding to be able to have a language program in each of their 3 schools. And let's say that the blue, red, and yellow dots represent families with non-native English speakers that are native in another language. So how could we best draw our lines for our school districts so that we can have one school with a language program for each of those 3 languages, and then the families are in that district. So that's kind of some context for it if you want to think about it that way. Okay. The 4th criteria is political fairness. Now, hopefully, with the idea of the commission is to avoid the possibility of having strong political bias one way or the other. So again, there's 4 Republicans, 4 Democrats, 5 independents, and they can't pass anything unless they have a majority of support and then 1 person from each party supporting anything they're passing. So, and then also they're doing everything out in the open. So that's the other thing. So it's going to be really hard to intentionally bias towards one political party or the other if everyone is watching you do what you're doing. So hopefully that won't be an issue. But in case it is, the districts have to be drawn so that they can pass accepted measures of partisan fairness. There's a couple different measures that are accepted. One that some people may have heard about is the efficiency gap. But then probably the one that is maybe more commonly accepted is the seat vote curve. So I have an example up here. So these are results from Minnesota in 2016 and Ohio in 2016. And this right here represents the percentage of votes, the percentage of the votes that the Republican Party received. And this represents the percentage of seats that the Republican Party received. So right here, this is 40% of the votes. So if the Republicans received 40% of the votes, they received 20% of the seats in that case. Now, how do we know what that would be, right? Because somewhere along here is the actual result. So the percentage of votes that the Republicans received and then the number of seats they actually got is somewhere on here. So how do we figure out all the other possibilities? So how this is calculated is you look at the actual outcome, and then in each of the districts, each of the districts has a percentage of Republican votes. And you use something called uniform partisan swing. So what that does is it says, okay, let's say overall the whole state got 2 extra percent of votes going towards Republicans. So the whole state went up 2% in favor of Republicans. We're going to assume that that happened the same in every district. So every individual district went up by 2% in favor of Republicans. So that's what the uniform partisan swing means. So if the percentage in the state rises, the percentage in the individual districts rises by the same amount. It's proportional. So what they do is they look at all those hypotheticals. So if the Republicans got 2% extra or they lost 2%, how would that impact the number of seats? And then they look at the way the maps were drawn and they say, okay, so we got, if we get more votes, then we would get this many extra seats based on how our map was drawn. And then you get this, which is our seat vote curve. So what happened in Minnesota is you got a shape like this, and in Ohio you get a shape like this. And if you take a few minutes to think about it, one of these seems more fair than others, than the other one. And we can kind of see why that is over here in Ohio. So right here, so when the Republicans got 40% of the vote, that's when they hit 50% overall. And then they got more than half of the vote anytime they got 40% or higher, right? Whereas over here in Minnesota, this goes almost through the origin right here. So almost at, I guess it's not the origin, 50% and 50%, right? So getting about 50% of the vote guarantees you about 50% of the seats. There's something called, what's it called? If you get a little bit over 50%, you're more likely to get a lot more than 50%. So it goes up drastically once you kind of hit the 50% tipping point. And there's a reason for that. It has to do with you've got kind of like more discrete districts. And so you're gonna, if you get over 50% in a few districts, you're gonna win the whole seat for that whole district, even though you're just a little bit over. So that's why that happens. So in this seat vote curve, a shape like this is what we're looking for. So we wanna see symmetry here. So this is basically saying that the Democratic and Republican outcomes would be the same depending on how the people are voting. So if you have the state leaning more Democrat, then overall the seats are going to lean more Democrat. If you have the state leaning more Republican, the seats are going to lean more Republican, and they're going to do that in exactly the same way. Whereas in Ohio, that was not the case, right? So it was more favorable to Republicans no matter how the state voted. So this is one way of measuring partisan fairness. Okay, so here's my third puzzle. So this is where the name Paloku came from, is these redistricting kind of grid maps that I've had my students do in the past. So the idea here is kind of examining how extreme we can go with drawing our lines. So how is it possible that we can draw these lines so we get results that are very skewed? And this is an example of this. So this one is an 8x9 grid, so there's 72 total squares. We're going to assume that each square is a person or 10 people, whatever we want to give it. And the diamonds are going to represent one party, and then the blanks are going to represent another party. Now, if you look at this, there's a lot more blanks than there are diamonds. I think it's 28 diamonds and 44 blanks. So it's kind of close to half, but not quite. And what you're doing with this puzzle is you're trying to do two things. So the first thing is, can I get the blanks to win every district? So there's going to be 6 districts, and we want the blanks to win all 6. So that's the first goal. So in doing that, we can see how drawing the lines in a very particular way can give us a very skewed outcome, because this would mean that the blanks are winning every single district, even though they have just over half of the population. And then the second task is, what can you do with a minority political group? So if you have a group that has less than half of the population, can we get it to win more than half of the seats? So in this case, we're going for the diamonds. And we want the diamonds to win 4 districts of the 6. And if you do a little bit of math here, you can see why I picked out 4. Because, so there's 72 squares total. So if I'm drawing 6 districts, that means there's going to be 12 squares in a district. Which means to win a district, you have to have 7 of the 12 squares. So 7 to win. So, and remember that we had 28 diamonds and 44 blanks, right? So if I need 7 squares to win a district, 28 divided by 7 is 4. So the most I could win with diamonds is 4 districts, because I just don't have enough to win more than that. But then the blanks, I can win all 6, because 7 times 6 is 42, and I have 44 blanks. Now sometimes it depends on how these are distributed, so this is where kind of making these puzzles gets interesting. So that's one thing that I kind of played around with, like how can I distribute the blanks and the diamonds to make it more or less difficult to accomplish these things. But this is kind of like a classic redistricting puzzle. So if you want to try this is a fun one. Oh, and one other thing I'll add is that I frame this in terms of political fairness, but in what this is really an exercise in gerrymandering. So this is what we don't want to do. But you can, in addition to partisan gerrymandering, there's also racial gerrymandering, and this still happens, sometimes intentionally, sometimes unintentionally. But you can also imagine how this could play out in terms of racial minorities. So how can I crack or pack these racial minorities to limit the voting impact that they have? So cracking is where I break apart things so that they don't win any district, and packing is where I pack them all into one district. So when you're doing the diamonds one, you're probably going to be packing. So if you make one district that's all blanks and pack them all into one, then you're not going to have as many blanks that will go in these other ones. Okay. Okay, so then we have no incumbent protection. This one, there's not a whole lot to say about this other than we shouldn't be intentionally drawing incumbents out of a district that they already have, and we shouldn't be intentionally manipulating a district to make it safer for an incumbent. It sounds like the Michigan Commission is not going to be using previous maps. They're probably going to start from scratch. One reason for that is that Michigan probably will lose a seat because our population has been decreasing. And so because of that, you're going to have to start from scratch anyway. But also, if you're starting from scratch, then it's going to be harder to to take into consideration the incumbents. In general, the best way to, I would assume the best way to not favor or disfavor an incumbent is just not use any information about incumbents at all when you're drawing the lines. And then reflecting boundaries. This is the sixth one. Again, I don't have a lot to say about this other than if you have county, city, and township boundaries, you want to try and respect those when possible. You can't always do it, but if you can, try and keep those intact. And that's just because those county, city, and township boundaries obviously are going to create a certain community of interest, right? Because there's policies that are going to affect different counties, cities, and townships. Okay, and then the last one is that districts have to be reasonably compact. So we saw that compactness is, we sometimes just can't get it when we're trying to get contiguity or to follow the Voting Rights Act. So there's a reason why this is the last one. I think that it's good that it's the last one. We generally want to have compactness because if you have a geographical area, then it's better to have people in the same geographical area, right? If you think about polling locations, where are you going to put your polls? How accessible are those to folks? If you have something that's spread out and kind of like a weird shape, it might be harder to get that. So we want to have compactness if possible, but it's kind of like our last priority. What I think is really interesting is this reasonably compact idea. And compactness is something that mathematicians in particular have had a lot to say about. And there's just a ton of different measures of compactness. So I'm going to pull up these shapes. This is another puzzle I'll tell you about in a second. But there's some measures have to do with like measuring the length and the width, the ratio of that. Some measures have to do with ratios of the perimeter to the area. You could look at the ratio of the area of the shape compared to the smallest circle that it fits inside, or the smallest convex shape that it sits inside. So there are, I think I read that there's over 100 kind of standard compactness measures. They all measure certain things, but then leave other things out. So there's not one agreed upon standard. And if you look at different state constitutions, like Michigan, a lot of times it's pretty vague what they mean by compactness. But in the reading that I did, I found a really interesting article called How to Measure District Compactness If You Know It When You See It. So this is by King, Kaufman, and Komisarczyk. And I have a link to that article also on my resources page. But what they did, this is really interesting, they basically said that if you look at court cases that have looked at compactness, there hasn't been an agreed upon standard. And so effectively, this eyeball test of looking at a district and knowing it's compact when you see it is basically holding up the same way that any of these other measures are. And so what they wanted to do is find a way of standardizing this idea of looking at a district and knowing whether it's compact or not, or comparatively how compact it is. So what they did is, and what I found interesting about this is their experiment was almost identical to an activity that I do with my math for liberal arts classes that I've been doing for a couple years, and their findings really reflected what I've noticed about what students do. So they gave people district shapes. So these are the kinds of shapes that I give my students. I give them polyomino shapes, and they gave them actual district shapes. And then they had them put them in order of most compact to least compact. And what they found is that there was a lot of consistency between people. So when they compared how different people ranked them, there was a lot of consistency. And they gave them like 100 shapes. And there was a significant amount of consistency. And then also, when they had when they had participants rank the same shapes several weeks apart, they also found a lot of consistency between an individual and themselves at different times. So basically, their argument is that the eyeball test is not nothing, right? It's not totally subjective. It's not just opinion. There's something there. So our brains, when we're looking at these shapes, are taking into account different measurements and different things. We're doing these calculations without maybe being conscious of it, and there's some consistency there. So what they did is they used all these rankings that everyone came up with, and they matched it to an algorithm that could kind of identify what was going on with the shapes, and this algorithm was really effective at estimating how people would rank their shapes. So I thought that was really cool, especially because it was so similar to what my students do. And then it really reflected the results I got from my students, because I give them, I think there's 12 here, but usually I give my students 10 shapes, and I have them put them in order, and then I have them hold up their most compact shapes and their least compact shapes, and they look around, and it is very consistent, very, very consistent. So I thought that was cool. I was really happy to find that article. So this is the last puzzle that I have, which is this. And if you go to the blog and you go to the Jamboard, it's nice because these are little tiles that you can move around and put them in order of most compact to least compact, and kind of see how you would rank them. How would you do it if you were just kind of using your own judgment? So, and the other thing that I think is interesting about kind of like throwing the standard compactness measures out the window is that the things that we value about district shapes are not necessarily the things that we value in terms of general compactness. So for example, a lot of these compactness measures compare to a circle. So like the circle is the ultimate compact shape. And mathematically speaking, it is, but when do we ever see circles on maps? So if we had a district that was actually kind of circular in shape, it would look weird, because we really don't distribute ourselves geographically that way. And then also there's certain things that we're more used to seeing more north versus more south, or certain kinds of symmetry that might be appealing. So the idea is that this eyeball test kind of takes all of that into consideration. So that is compactness. And then I have a couple resources on here. So I put some information on the Michigan Independent Citizens Redistricting Commission. You can watch all of their meetings. There's a lot of them. I've watched them all. There's a lot. Some of them are more interesting than others. But they also have they just have archives of information on there that you can view. And this one, if you just kind of want to like poke around and see what they're doing, if you go to the key 2021 dates for the commission, you can kind of get an idea of what their calendar is. In May, I believe, April or May, they're going to start going around the state and meeting with people. So they have a date kind of tentatively set for Grand Rapids. I think it's the beginning of May. So I think they've been talking about maybe using the DeVos Center or something. That might change, but they will be coming to the area, and you can go give your input and say, you know, I'm part of this group, and this is our community of interest, and we want to stay together when you draw the lines. Okay, there's some interesting maps. So these are ones that I use in the presentation. So there's the racial dot map. There's the legislative and Senate districts for Michigan from 2011 that you can view. There's games, puzzles, do-it-yourself map drawing. So Poloku, the redistricting. So that's my blog. And if you liked the district drawing puzzle, I've got a ton of those on there. And then the redistricting game is kind of a fun one. They have different tasks, like if you want to redraw with certain things in mind and then keep incumbents in place, or if you want to try and get a certain party to win, or you want to try and create a district for different racial minorities, that's a pretty fun game to try. And then Districtor, that is the one that I use to draw that state of Michigan map. That one is really cool. So you can draw your own districts for the state of Michigan, and they have information on there so you can kind of check that you're getting equal population, and you can just move stuff around so you get different ones. And I know they have the congressional option on there, and I think they have the legislative one. I don't know if they have a Senate one on there or not. But this is put out by the Metric Gerrymandering Geometry Group through Tufts University, which is a group of mathematicians that have really done a lot of work in getting the mathematics community involved with redistricting and voting. And so they put this out there with the goal in mind of making district drawing accessible for people. And so I suspect this has come up in the Michigan Independent Commission's meetings. I've heard them mention it at least once. I'm kind of hoping that whatever software they end up using will be able to take maps like this that people can just make on their own and kind of incorporate that information. I think that might be something that they're keeping in mind. There might be other software as well, but this is a cool one. One thing that is interesting, one reason why I wanted to do my sabbatical on this is because Michigan is one of a couple states that now has this commission, but I think this is going to be something that might be occurring in other states as well. And so when you take the line drawing out in the open so people can watch it happen and can participate in it, then you have to be educated on what that means, right? So what do all these terms mean? What do I need to communicate to them so that my interest is taken into consideration? How do I do that? And so there really needs to be some education on that. And so that was one of my motivations to doing more of these games and puzzles is, as educators, we know that you learn the best through doing something. So how can we create something that people can do that can help us learn about these things that we're going to now have an opportunity to take part in more. And then, okay, lastly, I've got just a couple articles and interesting readings. So this first one is that article that I mentioned about district compactness. And then there's the Jerry Monstered article by Mike Thompson. That's a cool one if you want to look at the individual districts. There's information about what the population is. I think it has like percentage that voted different ways, who the rep is. It's a little outdated. I can't remember what year it was from. Maybe 2012, something like that. But there's a lot of cool information in there. If you want to read the actual constitutional amendment, it's Article 4, Section 6 of the Michigan Constitution. So there's that link there. And then the University of Michigan information on communities of interest. So this is something, I'll put this presentation on my blog so that you can, if you want to go to, I'll put it in the same blog post as the problems are, so you can go click on these links if you want to read them. And then the other thing I wanted to say is that I am offering a Math and Politics math seminar, so Math 293, in the spring 2021. So it starts, I believe, May 10th, and it goes through June 28th. So it's the first 7 weeks. And it's Monday, Tuesday, Wednesday, Thursday from 4:30 to 6 p.m. So that time is to kind of accommodate people who might be working. It's going to be virtual, so it will be via Zoom. And we will be going into all of this in much more detail. We'll also be talking about voting, different types of voting. So if anyone's heard of ranked choice voting, we'll talk about that. That's something that's kind of gaining some traction in Michigan. So we'll look at all different types of voting systems, how to judge whether they're fair or not, We'll look at some of the particular compactness measures. We'll look at apportionment. How does apportionment happen? So lots of interesting topics, and we'll get a little bit more into the math behind it. But you don't have to have a strong math background. So you know, basic arithmetic is enough. So we'll talk about, you know, percentages and things like that, but there's no mathematics prerequisite. So I kind of designed it so that GRCC students can take it. So any political science students, math students, computer science students, geography students might be interested, but also anyone in the community who's interested in learning more. It's accessible really to anyone. So if you're interested in that, you can go to grcc.edu to enroll. And then also, if you have questions, you can feel free to email me. My email is my name, Meghan VanderMale @grcc.edu. And a new thing for me that I started during my sabbatical was I learned how to Twitter. So now I have a Twitter handle. So it's mvandermale. So you can also find me on Twitter as well. Thank you very much.